Hey guys, Dr. Brown here with Kubo Math, and tonight we're working a partial fraction problem that was given to me earlier, and it's taken me a little while to put it together. Sorry about that. Okay, so this is for a group at TSU here in Tarlock. So I've just left it on the board so I could walk through it quickly. Alright, so we had the integral of 8x cubed, and by the way, I'll be off the screen just because I'm trying to cover the entire board. So the integral of 8x cubed plus 13 divided by 4x cubed plus 8x squared plus x plus 2. Now factoring this dealt with the technique called grouping. So if you group 4x cubed plus 8x squared and then group x plus 2, you can factor the 4x squared out of this and end up with 4x squared times x plus 2 plus that original x plus 2. Now I can factor out the x plus 2. So I have x plus 2 times 4x squared plus 1. That's the key to the whole thing. Okay. Now, so that integral, since we factored it and we break it into partial fractions, it's a over x plus 2 plus bx plus c, since I have a second order here, over 4x squared plus 1. So now I'm going to multiply both sides by x squared times, or x plus 2 times 4x squared plus 1. And I'll just drop the integral sign for a little while till we figure out what our a, b, and c coefficients are. So if we multiply through by x plus 1, x plus 2, 4x squared plus 1. That cancels on this side. So I end up, the x plus 2 cancels over there, and I end up with a times 4x squared plus 1 plus bx plus c times x plus 2. So now we're going to choose, just, obviously there's some logic to this. If I choose a negative 2, this parentheses becomes 0, and I wipe out all of this and I can solve for a. So that's what we did. We have 8 times negative 2 cubed plus 13 equals a times 4 times negative 2 squared plus 1 plus all of that's gone. A ends up being minus 51 over 17, or negative 3. When I worked this the first time, I kept the negative 51 over 17 and worked it all the way through, because I thought, what an odd number. Anyway, that's my own stupidity. All right, x equals 0. We chose that. And then we ended up solving for c, and it was 8. So now we have a is negative 3, c is 8. So I have these two values. Now I just chose x equal 1. And of course, each time you solve and you figure out one of these values, you use it then as you go through. For example, now we have, if x is 1, I have 8 times 1 cubed, which is 8, plus the 13. Then I have the negative 3, which is a, times 4 times 1 squared plus 1 is 5. So you can see I walked through that. There's the c equals 8 that we had earlier. All right, we go through, so b equals 4. So now we have a is negative 3, b is 4, c is 8. So we have those values. So now we go back to this guy. We now have a, negative 3 times the integral of 1 over x plus 2 dx plus bx, b was 4, 4x plus c, which was 8, over 4x squared plus 1. So integrating that with respect to dx. The integral, this integral, is negative 3 times natural log of x plus 2. So I've circled it. And now I'm going to take to the top of the board this integral, and I'm going to break it into two pieces. So I break it into the integral 4x over 4x squared plus 1, and then the integral plus the integral of 8 over 4x squared plus 1. So I worked with each one of those. All right, so I chose u to be 4x squared plus 1. du is 8x dx. So du over 8x equals dx. So now just plug things in. I had 1 over u, or 4x over u, du over 8x. The 4 over 8 is 1/2, and the x's cancel. So now I have 1/2 the integral of du over u, which is 1/2 the natural log of u, and u in this case was 4x squared plus 1. So I have 1/2 natural log 4x squared plus 1. So I've circled it. So now I have two pieces of this equation. Now let's work with the 8 over 4x squared plus 1. So I pull the 8 to the outside. I let u equal 2x. So if u is squared, that gives me 4x squared. Okay, so du is 2 dx, du over 2 is dx. So du over 2, and this is 1 over u squared plus 1. Okay, so 8 over 2 is 4. So 1 over u squared plus 1 du. So now, hey, this thing looks like a trig sub. So a squared equals 1. U equals a tangent theta. Du is a secant squared theta d theta. So now I just plug things in. 4. And du is a secant squared theta d theta over a, well, I went ahead and squared this, so u squared to give me a squared and tangent squared, plus my a squared, which was 1. Factored out the a squared, put it over here, so a over a squared is 1 over a. I don't know why I kept it, because a is 1, it just goes away. So 4 over 1, secant squared, over tangent squared plus 1, which is secant squared. So those cancel. So now I'm just integrating 4 times the integral of d theta. So I have 4 theta. And what was theta? Theta was a tangent inverse of u over a. And u was 2x. So 4 times tangent inverse of 2x over a, and a was 1. Okay, let's put the three pieces together now. That integral that we looked at earlier is equal to minus 3 natural log of x plus 2 plus 1/2 natural log of 4x squared plus 1 plus 4 tangent inverse of 2x plus c. Okay, I can't imagine having 6 of those on a 1-hour test, but they did. Okay, so why are we doing this? Together we're trying to build a better tomorrow and do that through math. Okay, keep studying, guys. You folks that are studying for this upcoming exam, you're doing the right things. Work as many problems as you can. Challenge yourself, grow your mind, and I wish you all the best. If I can help at any time, let me know. Okay, we'll talk to you next time. Thanks. Bye.